Hello, so today I'm looking at M3 International A-Level, January 2014. This is question 2, and I can see that this is testing me on Hooke's law. It says, a particle P of mass m is attached to one end of a light elastic spring, meaning it can be extended or compressed. The natural length L and modulus of elasticity 2mg. The other end of the spring is attached to a fixed point A on a rough horizontal plane, rough meaning friction. The particle is held at rest on the plane at point B, where AB is half of L, and released from rest. The coefficient of friction between P and the plane is a quarter, so mu is a quarter. Find the distance of P from B when the particle first comes to rest. So the very first thing that I'll do is draw a diagram, and we can just draw the plane. So we have this spring where P is, and it is attached to a fixed point A, so we'll make that here. And first of all, the particle is held at rest at point B, where from A to B it's half of L. So if the natural length is L, and originally the distance from A to B is half L, then that means originally it's compressed. So I'll put B here, and this is L over 2, and so the natural length would be kind of up to about here. Okay, so this is where it is in the beginning, and originally it's at rest, so there's no speed. Okay, then it's released from rest. Then we have the coefficient of friction as a quarter, and find the distance of P from B when P first comes to rest. So the spring is compressed, so what will the spring do? It will go to its original length and probably a bit more than that. So this is the original position, and then later on we have that it's over here somewhere. So if I call this distance L, the natural length, from here to here, and then we can call this the extension. And it says it comes to rest over here, so here the speed is 0 as well. So in this case, then I know that energy is conserved because there are no external forces on the system. So I know that here there is no kinetic energy because there's no speed. I know over here there's no kinetic energy because there's no speed. There's no difference in gravitational potential energy because there's no difference in height. Here there is some elastic potential energy, and there's some elastic potential energy here as well. And in between here and here, there is some energy which is converted into work done against friction. So from here to here, I've got work done against friction. So basically, the energy that goes into the system, which was the elastic potential energy in the beginning, so elastic potential energy at B, that went into overcoming friction, and a little bit of it was left at the end, and to make some more elastic potential energy at its final point. So I'll call this, I've got AB, let's call this point C. Okay, so the formula for the elastic potential energy is lambda times the extension squared over 2 times the natural length. So here I know that lambda is 2mg, the modulus. I know the natural length is L. I know the extension originally is the distance from here to here, so in effect it's a compression. So that will be L over 2, which I'm going to square. So I have 2mg over 2l, and that's the lambda over 2l part, and then the extension is actually compression, so L over 2 squared. The elastic potential energy at the end will be very similar, so 2mg over 2l, and this time the extension is this amount here from the natural end of the natural length to this final position, so I'll just call that x squared, and I need to find this x. The work done against friction, well, I need to do a little bit of work to work out what frictional force is. So I know that if I have a force, a particle, the mass was m, so I have the weight is mg. I know that there will be a reaction force because it's touching a surface, and I know that friction will be equal to mu r because it's moving. So by doing Newton's second law vertically, I know that r is equal to mg. Therefore, I know that the friction is equal to mu mg. By using the formula, friction is mu times r. And they told me that mu is a quarter, so in fact here I have mg over 4 as the frictional force. So the work done against friction will be the frictional force multiplied by the distance over which that force acts. So the frictional force acts from here to here, so it's half of L plus x. Okay, so now I'm ready to start trying to tidy this up, and I'm trying to find out where x is. I think I'm going to end up with a quadratic equation. So I can see that I have mg everywhere, so I can divide everything by mg. Here I've got a 2 and a 2. What else? Here I've got a 2 and a 2. Okay, so let's just write this out again so that I can see a bit more clearly what's happening. Here I've got L squared on the top over L, so that would give me an L. And I've got a 2 squared on the bottom, so that's over 4. Here I have a quarter times L over 2, so that gives me L over 8. And then I have a quarter times x, so I get x over 4. Then from here I have x squared over L. Okay, so now I can, let's see, multiply everything by 8. So that will do this. And I can also multiply everything by L. So here I'll times by L, times by L, times by L, times by L. Okay, so after that stage, here I get 2 L squared. Here the 8's cancel and I'm left with L squared. Here I get again 2 Lx this time, and here the L's cancel and I'm left with 8x squared. So rearranging this so that I have 0 on one side, I've got 8x squared plus 2lx, and here bringing this over here I end up with minus L squared. So I can now work out what x is. I think I could use the formula, or I could use completing the square, or I'm not sure if factorising is going to work because I end up with a negative 8 L squared. Oh yes, okay, which would be 4L 2L. Okay, so if I do write 8x squared over here minus L squared, and 2Lx could be made from 4 Lx minus 2Lx. And factorising then, I get here 4x multiplied by 2x plus L, and here I get minus, open bracket, L outside the bracket, 2x plus L, and so I can see that this factorises into 4x minus L, 2x plus L. Okay, and so from that I can see that x will be L over 4, or x will be negative L over 2, which is actually where the initial position. Okay, so I can see that x is L over 4. So what was the question actually asking me? Find the distance of the particle from B when P first comes to rest. So in other words, I need to do L over 2 plus x. So the distance required is L over 2 plus x, and we said that was L over 4, so I get 3L over 4 is the final distance. Okay, so that is worth 9 marks. I hope you found that helpful. Good luck with your studies.